today we're going to start with the first foremost placement series, which is under operating systems, right? So as you have already seen in the thumbnail, we are going to work on the book, The Operating System Concepts by Abraham Silberschatz. And I also mentioned that Abraham Silberschatz is the famous book where we can use this book for your not only for your placement series, you can also use it for your curriculum. Why? Because major curriculum developers use this Abraham Silberschatz book for your for the as a base book for your operating system subject, right? So today we're gonna see the overview about it, right? So today we're gonna see the overview, right? So in this overview, what we're gonna see is, what we're gonna see is we're gonna talk about the introduction, right? Today we'll talk about the introduction, and you're also gonna talk about the system operations, right? So the major part is all about we're gonna dive much deeper into the concepts behind what operating system is all about, and I'm also going to tell about how the operating system is going to help the user to invoke the resources in such a way that the system resources. Let's see. So first and foremost topic we're going to learn about is what operating system is going to do. We're going to say what is operating system, we're going to define what is operating system is all about. Then we're going to talk about the computer system organization and the computer system architecture. We are going to talk about the computer system, like the systems what we are trying to use, the organization and the architecture, and we are going to dive much deeper into the operating system concept. Like we're going to talk about the operating system structure, the operating system operation, and then we are going to dive into the process management circle. The process management circle is all about we're going to make sure that the processes which is going to done by the operating systems and how we're going to manage the processes in terms of the terms of the process done by the what can I say operating systems. And in terms of then we're going to talk about the memory management. We already know there are two types of memory management. One is RAM, another one is ROM. And you guys know a base about what is RAM and what is ROM. We're going to just talk a little bit about that. Then we also have what is called as storage management, protection and security, kernel data structures, computing environment, and we're also gonna have about the open source operating systems. Right, so there are a lot to cover in introduction. We'll start diving into the first concept. Right. So I do a lot of question when I started seeing what is an operating system is all about. Right. So we need to know about what is an operating system. So let's talk about what it is. So operating system. Yes, I'm gonna have an OS over here, and I'm gonna have the user over here. Am I right? Let's talk about the user. It's gonna be the user like us, right? And we're gonna use the computer hardware. Let's talk about we're gonna use the computer hardware, right? So we're going to use the computer hardware. Let's talk about this. So the major part is nothing but the user is supposed to access the computer hardware. Yes, it is. Yes. Why? Because to make sure that if I want to present this screen, I'm supposed to use my hardware like keyboard, mouse, what can I say, the display, like my monitor, etc. and etc. I'm supposed to use those things in order to in order to present a video like this, right? In order to present my entire placement series like this. So I need to have an intermediary which can help me to access my computer hardware. So that intermediary is gonna call as the operating systems. I can able to call this operating system, I can term this operating system as an what may I say a system program or a software program. Let me talk this as a software program. Why? Because while we are addressing this, we're going to talk a lot about the software program management here. So I'm going to say the OS is going to be a software program which acts as an intermediary between the user of the computer and the computer hardware, right? Where I can able to use this OS to access the computer hardware, right? Clear? Yes. So now I do know about what is an OS. Yes, it's going to be an intermediary program, a software program, which allows the user to access the computer hardware efficiently. Now, what are the goals of the operating system? We need to know about what are the goals of the operating systems. Let's talk about, as I already said, that OS is gonna be my software program. So that's why I named the OS as a software program. So why I termed the OS as a software program. So I need to go back into go back to my context, that what is a software program is all about. So what is a software program? So let's take a small program, like let's take a small program like to find the palindrome of a number. So to find the palindrome of a number, we are supposed to have, an important thing is, we are supposed to have an input like a number or a string. We are supposed to process those input, and we are supposed to provide the output in such a case that given number is a palindrome or not. So there are three processes going to appear. We are going to execute the user programs where so that's going to be the program, right? So I'm going to execute the program by providing the input, and I'm going to validate the output with the help of the with the help of the things which is given out from that. So then make sure that, yes. So we were just talking about the operating system goals, right? So we are make sure that we talked about that we are going to execute the user programs and make solving user problems easier. As I said, operating system is being considered as a software program which is going to execute the user programs, the programs which is given by the user, and make sure to solve the user problems in easier way. And so once we also know about what OS is. OS is going to act as an intermediary between the user and the computer hardware, where we are going to make sure that OS is going to provide an efficient way to access the computer hardware. That means the computer resources. So we are supposed to make the computer system convenient to use. So the one of the important goal of OS is nothing but we are supposed to make the computer hardware, the computing resources, convenient to be used, and use the computer hardware in an efficient manner. Clear? Yes. So now let's talk about. So now you guys know about what OS is and what are the goals of the operating system is. Now let's talk about the computer system structure. What and all you have. Let's talk about that. So let's talk about. I'm gonna have a computer system structure over here. What are the things that we needed for this computer system structure? The first and foremost thing, I need to have the users, which is gonna apply. Like I'm gonna one of the main part about the computer system structure is nothing but the one who's gonna give us the instructions, the one who's going to give us the instructions to solve this problem or solve this particular problem or not. So the users can also be a people, yes, people like us, or the users can also be a machines, or user can also be a machine like how can I say, a physical machine, or you can also have other computers as your user. Am I right or wrong? Yes. So we can also have like this. Now the first thing, now we are supposed to have an OS in between, so that OS is a software program which acts as an intermediary between the users as well as my application programs. Am I right? So I'm gonna have some application programs over here. The application programs, which is gonna make sure that for which particular application we're gonna have it, and this is and finally we are gonna have the hardware. The first and foremost thing about the computer system structure is all about the hardware, the IO devices, the things what I'm right now using, the keyboard, mouse, monitor, etc. And it should have the CPU, and we should also have the memory which is needed to store the data, etc. and etc. is one of the important structure of your computer system, like one of the important components inside your computer system structure. So how it has been hierarchical, right? Let's talk about what this application program is all about. Let's talk about it. Let's take that. If I want to do a research work, I want to store each and everything as my documents, right? I want to store my documents. The documents consist of a series of lines. I want to store the document inside one kind of program, and usually what program will come to our mind, which is nothing but word. The word processor will come to our mind. So this is one of the application program in such a way that we can able to store our documents which is needed, like a kind of resource. Like we can able to say a particular kind of problem, where the problem is nothing but I have to store one of my resources, the which is being one of the resources, resources such as document. So the application program which defines a way where I can able to use the system resources efficiently to solve the particular computing problem, which the application program is also termed as. Here I'm going to use my application program is called as one. Let's take another example. If I want to present you, like for presentation, I'm supposed to use a Microsoft PPT, right? Microsoft PowerPoint. For the Microsoft PowerPoint, I make sure that I do have one single problem where I need to use this to present to you. I need to have one single. So that's the problem is I want to, what may I say, that's one of my computing problem. And one of my computing problem, I'm supposed to define a way in such a way that I'm going to use the system resources. What kind of system resources I'm going to use? That's nothing but my application program, the Microsoft PPT, the Microsoft PowerPoint. I'm going to use it. So the four different components are the hardware is the first and foremost thing, the operating systems, which also controls and finally the application programs and the users, the backbone of your computer system structure. Yes. Now let's talk about how it is going to be. And I don't want you to come. I want we'll be coming back to this particular diagram one more time. Why? Because I thought that coming back to the diagram after learning the what operating system is gonna do will help you a lot. Now, what operating system is gonna do? So let's talk about it. But because since we already know that OS is gonna be an intermediary. Okay, OS is gonna be an intermediary between. I'm drawing one more time. I'm drawing for each and every slide about how OS is being integrated. What is the particular precise definition? What is OS is all about, and you also have the, what may I say, the hardware. Let's talk about it simply. I'm gonna make sure that I'm gonna simply say it as hardware. Like, right. Let's talk about this. So the main point is all about what operating system is gonna do. That I should say, right now I'm working on a PPT, so operating system should provide me an interface such that it provides me the view so that I can able to present to you, and it also provides me a storage so to store this particular PPT. Or else, if I'm going to work on other cases, like if I want to store my document, I'm going to work in Microsoft Word, and I'm going to store and always also provides me the what may I say, the storage to store the operating system. So for each and every point of view, I make sure that the application programs I'm using, the hardwares I'm using are completely different. The it completely depends upon the point of view what we are working, and completely depends upon the particular use case what they are trying to solve. Right? That's the major case. It depends upon the point of view. It depends upon the point of view. And we already know about what kind of OS we're going to use. So the OS what we're going to use depends upon the performance. Like if I wanted to say that if I want to have a good performance and ease of use, why? Because that a very important thing. If you are going to buy a computer or a laptop for your personal usage, you will get to know about your performance range. Like I need to what can I say, satisfy all those things like display should be 550 nits and the processor should be this configuration, and display like the keyboard should be blue light keyboard, white light keyboard, or touchpad should be there, and graphics card should be there, what kind of processor I should have, each and everything we are we are so that's satisfied based on the performance, like what kind of what kind of performance that particular processor is going to have. So that based on the convenience about the users, right? So the use of use as well as the good performance, we make sure to we are not gonna care about the resource utilization. So we'll talk about lot about resource utilization in our next consecutive slides. And now I wanted to talk about what is mainframe or mini computers. So before knowing about OS, I want to talk about before knowing about the OS, you are supposed to know about the evolution of the computer systems. We started with the mainframe computers. The mainframe computers are the one which provides you the base for each and every standards of evolution of computer which has been started. And after that, we got the mini computer, and all those things made much more thing. But the mainframe computer, the size and space which is needed to fit a mainframe computer in a confined space it's considerably large. So we left from the mainframe computer, then we moved to the mini computer, and the disadvantages in the mini computer has been moved to a personal computers, etc., etc. Right, now let's talk about what workstations and servers is all about. You guys know about servers which takes about request and response as a two-way gateway services. So I don't want to talk a lot about it. Right. So from this point of view, I can able to say that what the operating system will do based on the point of view and based on the ease of use, based on the resource utilization. You should not care about the resource utilization, and it should have good performance. Right. So now let's talk about the perfect definition of an operating system. As I said, operating system, like I wanted to draw the diagram one more time here. Like I want to draw the diagram one more time here. Let's talk about that. So I'm gonna have an OS, I'm gonna have the user, and I'm gonna have the computer hardware. So I'm gonna have the computer hardware. The major thing what I'm talking about is the major thing what I'm talking about is the major thing talking about is the OS is gonna act as an intermediary between the user of the computer as well as the computer hardware, right? So where the user is gonna give us the access towards access to where the OS is gonna sorry the OS is gonna give us the access to gives us the access to the user to use the computer hardware for particular kind of use case problems. So this is what so far we learned about what is OS all about. So to make sure that OS should give us the access, or OS should give us the access to use the computer hardware. So the major thing is all about we have lots and lots of resources which is available inside a computer hardware. So the OS should allocate the resources to the user. For instance, let's talk about a very simple use case. I'm going to prepare a PPT where the PPT consists of all the slides regarding the Yes. So the OS is gonna allocate the resources for the users based on the problems which is gonna be solved by the user, right? So I want to talk about that. So the first and foremost, what can I say? The use of operating system is resource allocator. The first and foremost thing about OS is the resource allocator, and the second thing is all about so once the resource has been allocated, the OS should control each and every programs. It should control each and every execution of the programs inside the computer hardware, so that we should not end up with any errors or we should not end up with any improper use of the computer, right? So that's all about OS can also access the control program. So very important, guys, as I said. So this part is all about knowing the basic thing about operating system is all about. So the as I said, the OS is going to be an intermediary software program which provides you which provides you the access for the which provides you the access to access the computer hardware. So now right now I said that to provide the access to the computer hardware, the OS should allocate the resources to the user. So one of the important use of OS is the resource allocator, and the second important use of OS is the program controlling. Right, so that is what which is given over there. So OS is a resource allocator, and the OS is a control program. So which manage all the resources, decides between conflicting requests for efficient and fair resource use, and controls execution of programs to prevent errors and improper use of your computer. Right, clear? Yes. Now, let's talk about a continuation of the operating system is all about. So, as I said that I've talked about two important definitions so far, right? For the OSs, I've talked about OS and what may I say the intermediary software program, and we also talked about OS is going to be a resource allocator and also going to be control program which controls this thing. There are two definitions for OS right now we have seen, but the important thing is all about that this is not the universally accepted definition. Why? Because the thing is, as I want to say much cleaner is operating systems. We talked about operating system, right? The operating system, the OSs. We talked about this is gonna be an software program and which is gonna run inside a computer to give access to the user to use the computing resources. But a question comes to each and every mind that whether operating system will run for the entire execution of your life cycle? Not at all. The only one program. So that's which made us to talk about another more important thing called as kernel. Guys, I wanted to say that we'll talk about and we'll address operating system as a kernel in lot of slides, and the operating system concepts by Abraham Silberschatz book. He actually mentioned in such a way that he termed the operating system as kernel. He termed operating system as a kernel. So the one program running at all times on the computer is called as the kernel. So everything else is either the system programs or the application programs is either. So why? Because only we. So very important thing. Right now, I'm not executed the word. So what is not executed, but the kernel is running. So once we want to access the word, then I'll start getting to that word, and I'll start accessing I'll start accessing the word. So that's is all about application program, and based on the need, based on the time of need, I'm gonna use that application program. Not at all the time, right? But kernel is the one which runs at all the time of your computer. Yes, so far so good. Now, so the computer startup. Let's talk about it. So, if I want to know about that, some of you guys know about it. Why? Because in your basic computer classes, might know about how to start. Like, what are the things to be needed to start a computer? Right. So, first and foremost thing is all about the Bootstrap program. I wanted to say I'm not gonna say much a lot about this. Why? Because you guys know about it. So the Bootstrap program is such a way that let's talk about this. Whenever you start a program, whenever you start a computer, the first and foremost, sorry, I'm sorry, I've written as Bootstrap algorithm. Sorry, it's a Bootstrap program. Whenever you start your computer, the first and foremost program which runs inside our computer is called as Bootstrap program, where the Bootstrap program is loaded and power up or loaded at power up or reboot. Right, whenever you started to reboot your system or whenever you started to power up your system, the first and foremost program which runs is called as Bootstrap program. Where is Bootstrap program? The Bootstrap program will initialize, I might say it in a very clear way, which initialize the kernel. I wanted to say initialize the kernel. Yes, it is. It initializes the kernel, and moreover, the Bootstrap program is stored in one of the important place called as ROM or EEPROM, which is read-only memory or erasable programmable read-only memory, which is termed as firmware, right? Which is termed as firmware. Like, let's get to know about much details about it. I'm not gonna write much detail about it, because you guys know about what is ROM and what is EEPROM. And as I said, it's gonna loads the operating system kernel and starts the execution. Yeah, yes, so far so good. We are now gone some much of important things. Now let's talk about the computer system organization. Let's so computer system organization is in such a way that we're gonna have one or more CPUs, device controllers, connect through common bus, providing access to shared memory. The very important thing, guys. Why? Because we do have a CPU over here, we do have a disk controller over here, we have the USB controller which has been connected to mouse, keyboard, printer, and the graphics adapter which has been connected to the adapter. I'm able to see that it's been connected to a common bus over here, right? It's just being connected to a common bus where the common bus is being access to the memory. Why? Because this common bus is the only gateway where the CPU as well as the disk controller can be shared. The CPU as well as the USB controller can be shared. The CPU as well as the graphics adapter can be shared. Clear? And you can have concurrent execution of CPUs and device computing for memory cycles, right? So as I said, for resource allocating and like I wanted to mention you in one important way, guys. So as I said, the four components of your computing system. Let's talk about. We're gonna have totally n users, am I right? I'm gonna have totally n users. So user one is gonna access the compiler. User two gonna access the assembler. User three is gonna access the text editor, and so far so go. User n is gonna access the database systems. Now, wanted to give you much more aware that whether user one for whether the operating system should allocate resources for user one or user two. That's based upon the priority algorithm. We are going to talk a lot about this priority algorithm, guys. Like when I wanted make sure that some of the important algorithms are there inside operating systems where we need to discuss this priority algorithms, right? So whether user one gives more priority than the user two, or the user two gives more priority than user three, etc., and so forth. And which is going to access the system in application programs, which is nothing but your database, text editor, assembler, and the compiler, where you'll have the operating system to access your computer. Yeah. Yes. So just to give you an overview about how the concurrent execution of CPUs will be there. Now, the computer system operation. Like now we talked about the computer system organization. Then what is going to be the computer system operation? Now let's talk about it. Right now I'm using mouse. Right now I'm using keyboard. All those things are all those things are working concurrently, am I right? So I'm going to use, so let have a mouse over here, and I'm going to use a keyboard at the parallelly. I'm going to use all those things simultaneously, am I right? I'm going to use those things simultaneously. So these are going to be called as my IO devices, and when I executing these IO devices, my CPU also work. Okay, and these two things can execute concurrently, right? One concurrently, so can work at the parallelly at the same time, right? That's very important about operation is why, because so far so go, lot of computer hardwares are running parallelly, running concurrently, right? So is there any error came? No. So we are supposed to have a very important thing, that controller, the very important thing, the device controller. We need to inform the device. So device control, we do have another, so what can I say, thing called as device controller, where the device controller informs the CPU that it has finished its operation by causing it. So lots like device controller with control for each and every hardware is what we are using over there, right? So now yeah, so IO devices and the CPU can execute concurrently, and each device controller is in charge of particular device type, and each device controller has a local buffer, where the local, so when I want to talk about it, like I'm just giving you an instance, mouse will have a local buffer, keyboard will have a local buffer, CPU will have a local buffer, where the local buffer consists of some informations about the execution. Okay, CPU moves data from to main memory to or from local buffers. That's a very important thing. From this local buffers, the CPU will move the data, as I said. So for which thing I have to give the priority, right? So this is how the operation is going to happen. So how the computer system operation is going to work. So for each and every IO devices or anything else, like anything computer hard, anything, any computer hardware, the local buffer is the one where to and fro information can be passed from the CPU. And this device controller, like as I said, each and every device controller will have a local buffer, right? So the device controller which has a local, that means local buffer. Let's take, if I'm going to say that mouse operation has been done. So the mouse local buffer, the mouse device controller will inform the CPU in such a way that yes, my process is done. I'm not going to execute it more than one more time. My process is done. So I'm going to cast an interrupt over there, right? I'm going to cause the interrupt over there. Now, what is interrupt? I've said about what I've said about blindly, like the, what can I say, device controller is going to provide us the interrupters. What is an interrupt? So let's say that if I'm going to run a program from 0 to n minus 1, okay, 0 to n minus 1. So I'm going to run the program from 0 to n minus 1. So at one single middle way, if I'm going to have one single middle way, like let's take that at n minus k, my program has been stopped due to some other reasons. So in such a way that at some other reason, the program has been stopped at n minus k step, so where the interrupt has been occurred. The interrupt has been occurred. Now, how the interrupt can be, what can I say, rectified. So once the interrupt has been occurred, let's talk about, let me use another color pen over here. Okay, let me use green over here. So once the interrupt has been happened at this particular stage, which is nothing but my n minus kth step, right? So what I'm going to do is nothing but, I'm gonna, once the interrupt has been carried over, once the interrupt has been happened, I'm gonna call one important routine or one important algorithm called as ISR, which is termed as interrupt service routine. So with the help of interrupt service routine, interrupt service routine will consist of each and everything to be known to solve that interrupt. And how we are going to solve it? Through the interrupt vector. Interrupt vector will contains the addresses of the service routine. Okay, interrupt vectors. So let me call them like if I'm gonna have a vector like this, so it will contain, let's say it is 0x4. At the address 0x4, this interrupt service routine is being present. Right? Clear? So with the help of interrupt vector, where the interrupt vector consists of the address where the interrupt service routine is being stored, and with the help of the interrupt service routine, we can able to solve the interrupt which is being caused over. Yes. So interrupt architecture must save the addresses of the interrupted instruction. A trap or execution exception is a software generated interrupt caused either by an error or an user request. You guys know about it. The exception. I don't want you to talk a lot about it. Why? Because once we have seen, if you have majored programming languages Java or Python, or you can also take like if I wanted to give you and the object oriented programming language, you'll be seeing the exception. What is exception? Exception in such a way that it is not an error. If I wanted to say it is not an error, okay. Why? Because error cannot be rectified, but exception can be rectified with the help of the process. What we can do, it's a kind of error. Let me say that exception is a kind of error which can be. It's a kind of error which can be rectified. And for instance, if I want to give you some example, the arithmetic exception, which is nothing but your division by zero, which provides me the infinity, so the computer will not accept this. And null pointer exception, and some null pointer exception, array index out of bound exception, etc. Like that. And operating system is interrupt driven. Why? Because now I don't right now my system is working good, but at some point of time the system will get hang. Why? Because a kind of interrupt has been done. So we are supposed to drive the interrupt and make sure that the interrupt will be not happening one more time. Clear? So this is all about interrupt test, right? Sure. Now I wanted to give you some more instance, right? So now we know what is an interrupted, and we also talked about we're gonna solve the interrupt through an interrupt service routine, where the interrupt service routine address is being stored inside interrupt vectors. Now, how can we handle this? That's a very important thing. We are supposed to have how we gonna handle this interrupt. So the operating system preserves the state of the CPU by storing registers and the program counter. Okay, let's give you an instance. Let's take a program which runs from 0 to n minus 1. So, you guys know about it. At the 0th step, a program counter, like if I want to say that if you learn computer architecture, might know about some of the registers which is being used, right? So, the program counter is the foremost register which is used to, what can I say, which is used to find the number of lines of execution of your program, right? So program counter will counts the number of execution at this point of time. The program, sorry, at this point of time, the program counter value is 1. At the first step, program counter value is going to be 2. At the n minus 1 step, the program counter value is going to be n minus 1. We can able to check if the program counter value is n minus 1. We can make sure that the program is not get interrupted at such a way. And if program counter at 5 has been interpreted, and we when we get the output as 5, but we are supposed to get n minus 1 as a program counter in output, so we can able to say that yes, the state of the CPU is not at the particular point, it has been interrupted. Now, with the help of the program counter, we are make sure that what type of interrupt can be occurred, right? So we need to know about this, what type of interrupt can be occurred. So interrupts are of two types. Okay, one is, so there are a lot, I'm just saying in terms of context of operating system concepts by Abraham Silberschatz, but this is not the way. Like, this is not only this is not, I'm not saying, I should not say that it's not the way, but this is not only the classification of your interrupts. There are a lot of interrupts. So one is pooling, another one is vector interrupt system. One is pooling, another one is vector interrupt system, right? And separate segments of code determine what action should be taken at. So we do know about it. So vector interrupt system, so as I said, there are two types. So at when the pooling interrupt has been happened, there is separate segment of code should be happen. And when a vector interrupt system has been happened, then there will be another separate segment of code. So for each and everything, let me give you an instance over here. Like if I want to show you one more thing, like yeah, sure. If my interrupt is arithmetic exception, if I'm exception is arithmetic exception, that means division by zero. So for this, a separate segment of code is being done. If not so, if my null pointer exception has been arise, if the null pointer exception has been arise, for this I need to have another separate. For this I need to have the another separate line of separate segment of code. For each and every exception, I need to have another separate set of code so that it determines what type of action should be happen when that particular interruption has been or when the particular exception has been arised. Clear? Sure. So what's the interrupt timeline is? I don't want you to bore you with these things, because I don't like may say, guys. Right now, you know about what is an interrupt. That's my major goal is. Now, yes, if an interview ask about, get me know about an interrupt in what can I say, operating system, like measure, how can you solve it, what are the routines which has been followed, you can able to explain. Right. Let's talk about it. So let's talk about the IO structure. Right, and the very important thing is all about that the system calls as well as the system programs. And as I said, I'm not going to give you the overview of all, I'm not going to give you the in-depth view of what the system call as well as the system programs, but because it will take lots time to cover. But and I suggest that is not needed much for you, right, much for us right now. So I'm also preparing for it much for us. So let's talk about the storage structure, right? So let's talk about this, the system calls and system programs in next consecutive slide. So let's talk about what is a storage structure is. So what is a storage structure? Let's talk this in a very uh, brief way, right? Main memory, the large storage media that the CPU can access directly. Yes, am I right? Yes. Why? Because for right now, so you know about what is RAM is. RAM is a random access memory for each and every particular operation which is happening at particular point of time. We are supposed to access the content which is stored inside the RAM, and inside RAM we can able to store the entire information. Why? Because once the system has been completely locked off, the completely shut down, the contents which is stored inside the RAM will be completely erased. But it is not in the terms of ROM, but in RAM we do have faster access, ROM we don't have faster access. This is the overview all about it. So that's considered the main memory and typically volatile. That is the definition about what I've said about the erasing point of view. Secondary storage, extension of main memory that provides large non-volatile storage capacity. And you guys know about the hard disk, the HDD, which you have tracks and sectors. And I don't want you to mention you much deeper into what tracks, what sectors, what disk controller is. If it is needed, if we want to know about much detailed expansion about how the hard disk structure is being done, we are supposed to know those things. And now the solid state drives, the SSDs, which is being replaced, the replacement of HDD is also being done. Like as I said, storage structure is being very simple for you. And let's talk about the storage hierarchy, which is very, very important. The storage hierarchy, very important thing, right? I wanted to, as I said, why we stored like a very important thing, why we chose RAM as one of the major main memory, and to access the resources quickly, why we are stored why we are chose RAM. Why? Because the availability as well as the RAM's speed, right? Why? Because the speed in access in RAM is always fast compared to ROM, right? If I want to talk speed and also have cost comparatively, let's talk about the cost of RAM and cost of ROM and the volatility. As I said, the volatility is a very important measure you are supposed to know about it. Okay, before going into the storage hierarchy based on these three conditions, which has been arranged in the next slide, I want to know about what is catching is all about. Okay, I want to know about what is catching is all about. So catching is nothing but I wanted to what can I say, we have a RAM, and if guys know about it, we also have one more thing called as cache memory. Why? Because if I want to access something, I'll switch from cache to RAM, from RAM to cache memory, so that user can access the cache memory to access the resources as quick as possible. Why? Because cache is not so big, not so large storage, but it can have faster access. And device drivers, the input drivers and output drivers, which controls the devices. Let's talk about the storage hierarchy based on speed, cost, and volatility. Okay, the first thing is all about registers. Okay, so if I want to say the cost of cache is comparatively large, so it has been arranged in the range of cost. So this is high and this is low, right? And availability, caches are high availability, so cost we can also take it as an availability, and volatility, it has high volatility. Why? Because the content stored inside cannot be what can I say, will be not be there once the system has been shut down. So main memory, solid state disk, hard disk, optical disk, and man. So starts with the register, go for the cache, main memory, solid state drive, hard disk drive, optical disk, and magnet takes up the storage device hierarchy, which has been arranged in the form such a way that cost, availability, and volatility from high to low. Clear? Yes, so as I said a lot about catching, I don't want to do so much about catching is right. The very important thing, DMA, direct memory access structure. So we'll see about the overview of all those things what we have seen so far. So what is direct memory access structure? So to access anything which is present inside a memory, right, we need to have an intermediate. Okay, but if I said, can't you directly access your memory for your main things? Yes, it does. Why? Because you have a device controller which transfers the block of data from buffer storage to main memory without CPU intervention. As I said, for each and every IO devices, we do have a device driver. We do have a device driver, and inside the device driver, we have a local buffer. Am I right? So we talked about this in which slide? We talked about this in this particular slide. Am I right? Wait. Yes, we talked about this in this particular slide when we are talking about the operation of computer system. Right. So yes. So we need to go for CPU, and the CPU is the one it will access the local buffer for the operation point of view. So that then the CPU will access the memory. The CPU then will then access the your memory. But I wanted to give you an definition. Why can't the IO devices can directly access the memory without the intervention of CPU? Yes, it is possible. Then it is called as direct memory access, right? So, but you can ask, any is there any interrupt can be generated? Yes, only one interrupt is generated per block rather than one interrupt per byte. You can able to say per block one interrupt is being generated, not per byte, I should say, not per byte. Per block one interrupt has been generated, not per byte. Clear? That's is all about. There are a lot to know about direct memory access structure, guys. To give you an overview, this is enough, right? So yes, and there's the Wants Newman architecture where you can access. Let's talk about this. The threads of execution. We'll talk about threads in the next chapter. What we're gonna get into about the instructions and data and about the devices. As I said, this is gonna be the direct memory access without the implementation of without the intervention of CPU. As I said, right. So I'll talk about threads of execution and other important things which is needed for you in the next chapters. Okay, right, let's talk about the computer system architecture right now. So we have seen a lot. We talked about what is an operating system is, what operating system is do, what is the particular definition of the operating system. We talked about the computer system structure, the computer system operation based on the local buffer, and we also talked about the other thing like as interrupt, dealing with interrupts, and some other things. Like so far we have seen about a storage hierarchy, storage definition. We have seen lot about it. Now let's talk about computer system architecture. What is computer system architecture? We know that right now we are not working with single processors. Am I right? Yes. Right now, no, we are not working with single processors. All are going to be called as multiple processors. And these multiple processors are growing in use and importance. Okay, and we also talk them as all also known as parallel system. Why? Because we should not have instructions should not follow one after the other. Why? Because once the instructions follows, the throughput. You guys know about what is the definition of your throughput is the amount of work done in a amount of work done in a given time. So it is less, right? So we are supposed to what can I say, execute the instructions parallelly in such a way that we are going to have high throughput and tightly coupled systems. And as I said, what are the advantages include? The increased throughput. Yes, I do have increased throughput, economy of scale. Why? Because when if I started building up the multiprocessor systems, the scale, the economy which is needed for your scale is less. Why? Because when I build one multiple processor systems and n single processor system, I'm sorry, one single one single processor system, the cost which is needed to build one multiple processor system is less compared to cost building up n single processors system, right? This is one. And we also have increased reliability in such a way that if it is any fault tolerance, that means let's talk about, if I'm gonna like let me rub all those things. This is like just for your instance, right? Yes. Now if I talk about you that, right, if I have one multiprocessor systems which consists of all the single processors which we have, let me give you an instance. If I'm gonna give a work called as D for this particular processor, but this but this one single processor has been failed, whether the D will be stopped? No, the D work is being passed to the this processor. So in reliability in such a way that if one processor cannot able to do the process at a particular point of time, the other processors will share the work will share the work. So these are the advantages of multiple processor systems. So first thing is all about throughput. The second thing is all about ease of scale or ease of scale. And finally, we have the increased reliability. Let's talk about it. We also talked about that increased reliability. As why I'm specifying it, you guys need to know, right? As far as what are the advantages of multiple processor systems. Okay, now let's talk about what are the types of multiple processor systems. So, what are the types of multiple processing system? One is asymmetric, another one is symmetric. One is asymmetric, another one is symmetric. So what are the things which is there in asymmetric and what are the things which is there in symmetric? Let's talk a much detailed about this. So what is asymmetric multiprocessing and what is symmetric multiprocessing? Asymmetric multiprocessing, each process is assigned a specific task, right? In asymmetric processing, each and every processor has been assigned assigned with one. So assigned with one specific task. Okay. And symmetric processor is each performer performs all the task. Okay. So let's take work as D. All the processors will work on this D processes, task. For instance, each processor, if I want to give D, will be associated with only with this processor, right? Okay, let's talk a bit. What can I say? Like bit depth about what is asymmetric multiprocessing as well as symmetric multiprocessing. This is the symmetric multiprocessing architecture. Let's talk about it. Let's say that in symmetric multiprocessing, I've said in terms of symmetric multiprocessing, in terms of symmetric multiprocessing, we have all the processors will work on the task. So make sure that if all the processes want to work on the task, each and every processes should have a common memory. Am I right? Each and every processor should have a common memory so that it can able to share. Let's see how the architecture has been built. We have a common memory over here. I'm going to have a common memory over here, and we have a registers and a cache for each and every processor what we have, and so that it is being shared through a common bus. It has been shared through the common bus. Clear? Clear about symmetric processing architecture? Okay. This is a dual core design. Okay, so dual cores is nothing but I'm going to have two cores. That means so now you have a dual core and multi-core chips. What do you have? So dual core is nothing but you have two processors in one single chip. And clustered systems is all about you're going to have what may say, let me talk to you that clustered system is nothing but as we seen over here, each and every CPU has only connect toward this particular base, right? But in terms of cluster system, multiple systems working together and using storage via storage area network. I wanted to give you much overview about it. The storage area network and provides high availability and asymmetric clustering, symmetric clustering. We have lots and lots of those things. I don't want to talk much about it, right? So some clusters are for high performance computing and distributed lock manager. It's a very important. Like let's talk about this. So we are gonna have usually share of having those things. So as you're talking about it, so cluster systems is was such a way that multiple systems working together, and we do have via a storage area network, high availability, and you can also have there are two types of clustered systems. One is asymmetric clustering, another one is symmetric clustering. Asymmetric clustering has one mission in hot standby, as that means you'll have an what may I say a master slave concept over here in asymmetric. Why? Because master will give the order to the slave and slave will work based on the orders which is being given by the master. In symmetric, all the processes, like if I want to say the same thing, all the processes will work on the applications, right? And we have the high performance computing, as I said, the HPC, high performance computing through parallelization. If I wanted to give you an overview, the parallelization concept, okay, I'm gonna have the parallelization concept, and some have distributed lock manager to avoid conflicting operations. The very important thing, if I'm gonna lock, like we need to know about for which process I need to manage it, so that I need to lock all the other distribution over that. So that's the major thing about the distributed lock manager. We'll talk a lot about distribution lock manager when we are talking about it. So this is what I've said. Yes, right now, so we have seen about, yeah, yes, now I got to know about this thing. Yes, so we talked about symmetric multiprocessing and what is all about asymmetric multiprocessing, right? So what is all about asymmetric multiprocessing? Let me drop these things. Okay, let me give you an instance. The asymmetric multiprocessing. In terms of asymmetric multiprocessing, as I already said, in terms of clustered systems, we're gonna have master slave concept. Master slave is nothing but you have master processor and you have lots of other slave processors. The thing is, the master processor will start giving you the orders to the slave processors, where the master processor will just give you the order. Come on, this slave, come on, do this process, do this process, do this process. That's it. Master will just coordinate all the slave processes and controls them. That's the asymmetric multiprocessing is all about. But in terms of in symmetric multiprocessing, each and every processors will work on it, not giving, not having any concept like master or slave. Right? So yes, we get to know about that. Yes, sure. Right, okay. Right, now let's talk about what is operating system structure is all about. Right, and I wanted to give you an instead. Yes, so, okay, let's talk about the operating system structure. So what is an operating system structure? So right now, so we have seen a lot like what is an operating system and what is all about, and computer system architecture, computer system operation, computer system each and everything which we needed, the interrupts, what we need to know, and the operation. We talked about the local buffer concept, and we also talked about the memories what we have, and we also talked about the direct memory access structure, caching, and we also talked about the computer system architecture in such a way that we talked about asymmetric multiprocessing and symmetric multiprocessing and cluster systems. So there is somewhat needed for this thing. So we'll see this in the next consecutive classes about the operating system structure and the entire part of the unit number 1, which is nothing but the overview of the introduction about the operating system overview, so that we'll get into the chapter number 2 in unit number 1 in the next consecutive classes. So thank you for listening. So hope you get to know about it. So follow, subscribe for this channel so that you get to know about each and everything which is needed for your placement preparation. So right now we've started operating systems, and hopefully we'll be starting our system designs as well as our database management system things as quick as possible. Thank you.